Okay, so the first thing you need to understand for these questions is that what we're doing when we find when two curves or lines touch or intersect, anything like that, we're doing simultaneous equations. And you've actually done simultaneous equations with quadratics a lot already without realizing. So let me just explain that real quick. If we take this particular one, x squared minus 2x plus 3, actually, just for the moment, I'm going to make it a minus 3. Now, if you were to factorize that to find the roots, which would be -1 and 3, what you're actually doing is you're solving it to be equal to y equals 0. Okay, so this is a simultaneous equation that you've done a lot. So what that means is, if we know that y equals 0, y also equals x squared minus 2x plus 3. Hence, if y equals y, then 0 equals x squared minus 2x plus 3. And then we factorize and we use our null value theorem to figure out what x is. This is all stuff that I know you can do. The reason I'm explaining this is I want you to see that you've already been solving simultaneous equations with quadratics. So all that's changed here is instead of 0, we have y equals mx minus 6. So let's just think about this for a second. If instead of 0, y equals mx minus 6, we can see that based on the value of m, this line changes its gradient, and so it could have no points of intersection with the parabola. It could have 2 points of intersection with the parabola. It could have 1 point of intersection with the parabola here, if it just touches there, or if it just touches there. So let's think about what this means in our question. A is asking when does it touch the parabola, and B is asking when does it intersect the parabola. So what that means is A wants us to figure out what are these values where it just touches, right? And then part B is asking for all of these values where it crosses, where it actually intersects with it. Okay, so this means we have y equals y, so mx minus 6 is equal to x squared minus 2x plus 3. Now that probably looks scary and confusing. You're like, but before it was equal to 0 and that made it easy. So let's make it equal to 0. So we add the 6 to both sides, we subtract the mx to both sides. We're going to get that factorization, the 2 plus m. I did that kind of quickly in my head, but if you move it across and factorize, you're going to realize that that's pretty easy to understand. Okay. When does this touch the parabola? Well, if we think of our quadratic formula, so quadratic formula says x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. If our line doesn't touch the parabola at all, what that means is the discriminant is taking the square root of a negative number, which we can't do. If we touch exactly once, if we just touch it, that means that our discriminant is equal to 0. So to answer part A, we just need to solve for when the discriminant is 0. So we say b squared minus 4ac equals 0. Right? So just in case that wasn't clear, this part here is called the discriminant because it helps us discriminate how many solutions the question will have. If it's negative, 0 solutions. If it's 0, there will be 1 solution. And if it's positive, there will actually be 2 solutions because then the plus minus is going to come into play. We'll have plus this and minus this. It gives us 2 answers. All right, so in this equation here, the b is minus 2 minus m. So that's squared. And we have minus 4. A is 1. And c is 9. All right, so this 4 times 9 is 36. It's a negative there. I'm going to leave it on this side for the moment. Now this one, I'm going to expand and just kind of hope that you can follow along. I'm going to use the formula for a perfect square. So we square the first one, then we multiply them. Negative 2 times negative m is positive 2m, and we double it, plus 4m, and then we square the last term, plus m squared. And that's a negative. Okay, so what you can see here is we actually have another quadratic, just to make life fun. So we want to know what values of m make this equation true, equal to 0. So let's just solve it as a quadratic. we have m squared plus 4m minus 32 equals 0. What adds to 4 and multiplies to negative 32? Well, that would be a positive 8 and a negative 4. Okay, so that tells us that m must be equal to negative 8 or positive 4. So let's just check that real quick. If I make m 4, oh, and hold on, I need to put that back where it was. Ah, there we go. It really does appear to touch it just once. What if I make m equal to negative 8? Ah, and there's the other side. Perfect. So that's our answer for A. M equals negative 8 or 4. All right, now we want to know when it will intersect the parabola. Now, we can just fiddle on Desmos and figure this out really easily, but I want to go through it more carefully just to kind of help you understand how to do it algebraically without a tool such as Desmos. So if it intersects the parabola, that means the discriminant will be positive, right? Because if it was 0, we just touch it, and if it's negative, we don't touch it at all. So if it intersects, the discriminant's positive. Okay, so that would be like if we redid this, but instead of equal to 0, we said is greater than 0. Okay, so I'm just gonna like skip a bunch of lines of working, and let's take this, and real quick, we want to visualize, because it's m squared rather than negative m squared, we know that this is going to be some type of smiley parabola. We've actually found its roots. We've got negative 8 and 4. This drawing's not to scale. And we want to know where this is greater than 0 this time. So we can actually see quite easily that that means that m is less than negative 8. Anywhere over here it's above 0, or greater than 4. Okay, so we already found the answers. We just need to know which side of them we care about. So we can say m is less than negative 8, or m is greater than 4. And then the last one says, where does it not intersect the parabola? Well, that is, again, when this thing's negative, so anywhere between negative 8 and 4. So negative 8 is less than m is less than 4. Boom. Awesome. So by equating the two given equations, straight up, they're telling you this is a simultaneous equation question. So we just need to equate them, and we need to rearrange it to find a quadratic in terms of x and a, right? So basically, like we did up here, where we equated them and then we moved everything to one side to turn it into that quadratic, that's all we're doing down here. So we have y equals ax squared, and we have y equals 12x plus 3. If y equals y, which it definitely does, then that means that ax squared is equal to 12x plus 3. So let's rearrange things. So 0 is going to be negative ax squared plus 12x plus 3. I don't like the negative a part of that, so I'm just going to say flip everything. Ax squared minus 12x minus 3. Okay, that is a. That is what a is asking for. 0 equals ax squared minus 12x minus 3. Now, by using the discriminant, find the value of a. Because we know that the y equals 12x plus 3 is a tangent, okay? That's a key detail here. Because it's a tangent, that means it touches once, which means the discriminant is 0. So just a reminder, the discriminant is b squared minus 4ac. This is the part under the square root in the quadratic formula. So if that's equal to 0, well, b here is negative 12. A is a, how convenient, and c is negative 3. Okay, so we have 144 plus 12a equals 0. So 12 plus a equals 0. A equals negative 12. Okay, boom. A equals equals negative 12. Find the coordinates of the point of contact between the tangent and the parabola. Okay, so what this is actually asking you to do, so we know the value of A. That's basically telling us the steepness of the parabola. I think we're just plugging it in here and we're solving for x. So we just put a dot, dot, dot so we can see that something has happened. 0 equals negative 12x squared minus 12x minus 3. I'm going to divide everything by negative 3. So we have 4x squared minus 4x plus 4x plus 1. Okay, so what adds to 4 and multiplies to 4? That's going to be 2 and 2. So we have 4x squared plus 2x plus 2x plus 1. So we have 2x times 2x plus 1 plus 2x plus 1. In other words, we have 2x plus 1 times 2x plus 1. Okay, this is equal to 0. So that means that we can square root both sides. 0 is equal to 2x plus 1, which means that x is equal to negative 1 over 2. Okay, so that's half of our answer. Then we just need to come up to either one of these and plug it back in. So I'm going to use this one because it doesn't have a squared. So 12 times negative a half will be negative 6, plus 3 is negative 3. Okay, sketch the parabola and the tangent line showing the coordinates of the point of contact. So the parabola is negative 12x squared, right? Because ax squared and a is negative 12. So it's going to go through the origins, got no y-intercept, so it's 0, and it's super steep, like much steeper than what I'm actually drawing. I'll pull it up in Desmos in a second. And then the tangent line is at a point which is like maybe here, negative 1/2, negative 3. And so that tangent line is going to be something like this. Now, of course, if you were doing this in class, you would be doing this with a ruler and you'd be way more careful. But this is the shape of what we're going for. So let's just confirm that. And so here we go. It's a little bit kind of hard to see because everything is so steep. But that's approximately what we were picturing. Awesome. Good fun. Good fun. I liked these questions a lot. Thank you very much for sharing. Let me know if you have any more questions.